sure the bridge don't fall down, right, and kill 20,000 people or whatever. All right. Are we good with that one now? Yeah. All right, well, let's do one more and get out of here, right? It's Florida. Let's get out of here. 27. The velocity of light. Well, and of course that's the one where the velocity of light was incorrect. All right. So I made the change there. There was a typo in the book, and yes, I'm sure about that. Okay. The real velocity of light, as you can see over there, is 6.7 times 10 to the 8th miles per hour. So let's write that down. All right, I guess actually that's a speed of light. As I was talking about before, a speed and a velocity are very, very similar. A speed is just what's called a scalar, one number. Or a velocity is a vector, and anytime you talk about a velocity, you have to talk about how, like as this right here, velocity, how fast and in what direction, you know, perpendicular to this or that or whatever. Okay, now here's what we got. The distance from Mercury to the Sun. So let's draw us a little picture here, right? So there's the Sun, and then over here somewhere is a planet orbiting called Mercury. Now the literature tells us from here to here there is a distance, and it says that that distance is 5.78 times 10 to the 7th kilometers. Now here's what it wants to know. How many minutes will it take light to travel from the Sun to Mercury? All right. So in other words, if the Sun was to randomly burn out, how long would it take the light to stop hitting Mercury? Okay. So here's what we got. Let's write down 5.78 times 10 to the 7th kilometers. Now this is in kilometers, and that thing right there is in miles per hour. I don't like that. So what do you want to change? Do you want to change this one to miles or this one's to kilometers? Change this one to miles. All right. Now listen, you can do either one. They are both right answers. But generally now, if you start taking these standardized tests or whatever, okay, you do not want to play around with a constant. All right. Because, you know, studies have shown that you're going to have more error if you do that because you might be wrong. Always if there's a constant and you can keep from tinkering with it, do that. Sometimes you can't. All right. Now, if she wants to do that, it's fine. You'll get the right answer if you do it right. Okay. Here's what we got. We got kilometers here and we got miles up here. So, what have we got? What's the conversion? 1.609 kilometers in 1 mile. Now that's gone. Looky here. The 6.7 times 10 to the 8th, is that married to the mile or is that married to the hour? Up here. Is it right next door to the mile or right next door to the hour? To the what? To the mile. All right. So here's what we got. We got 6.7 times 10 to the 8th miles per 1 hour. Now notice I flipped that, and that's okay as long as that number stays right side beside the mile. So that tells us how many hours it would take, right? But what does the problem want to know? Does it want to know hours? Minutes. So we've got to do one more step, right? I know that in 1 hour there are 60 minutes. And that's going to do it for me at 5.78 times 10 to the 7th. Well, does anybody know just from pop culture about how long it would take for the sun, if it burned out, the light to stop hitting the earth? What now, 8 minutes? 7 or 8 minutes, something like that. Okay. So would you expect it to be less than 7 or greater than 7 or 8 minutes? Well, let me see how let me ask how right. I'm kind of thinking how I worded the question, right? Mercury's the first planet, so you would think it would take less time, right? Okay, so I'm looking for an answer less than 8. And I can't stress to you how important that is to be sure. I know I've said it 27 times. be sure your answer is reasonable. All right. So many times that has bailed me out of jams in so many advanced science classes and so forth you would not believe, is you step back and you say, is it reasonable? Okay, if it's not reasonable, guess what? You know what you've probably done if you're a good student that's not out to lunch? You've probably just flipped some very simple problem. All right? I mean, naturally, if you're out to lunch and don't have anything on the paper, what can you do, right? But probably if you've just messed up something a little bit, it's just a very minor fix if you can go back and find it. Change a negative sign, something like that. So 3.2 minutes, right? My answer's consistent. You guys told me that. Earth's way over here, 8 minutes. Mercury's over here, so you would expect if the sun was to burn out, light would stop coming there first and then stop coming to the Earth later. Are we good? So here's what you need to do. Go home tonight, finish working these problems out of Chapter 2. If you got anything at all, I'll answer them tomorrow. We'll do our lab on density and measurements tomorrow. And then we can do Chapter 4 and 3 next Monday. All right, probably. All right, very, very short Chapter 3. Chapter 3, we go into, instead of this math development, we go into periodic table, what the things mean, the abbreviations, and the whatnot. Has anybody got anything else? All right, we'll see you.